This part of the video will cover the breadboard demo for the Laboratory 3. The first logic gate to be demoed is the hex inverter or the NOT gate with the code 7404. In this setup, we first place the dip switch and secure a line for the power needed in the circuit. We place the NOT gate in its desired place, attach the VCC pin of the IC into the positive line of the circuit, and connected the ground to the negative source. Following the schematics we did beforehand, and it's done. Now let's test out the circuit. As shown in the truth table, the output will only be high if the input is 0 and low if the input is 1. In other words, they are inverted. The second logic gate to be demoed is the OR gate with the code 7432. This setup will just be the same as the inverter. The only difference is that there will be two inputs. Same as before, we just need to follow the schematics that we did in the simulation for the OR gate, and that should do the trick. Now that it's done, we will test our circuit using our logic probe and tally our test results. As shown in the truth table, the output will only be high if at least one of the inputs are high, and low if there are none. The third logic gate to be demoed is the AND gate with the code 7408. This setup will be just like the OR gate that we made previously, in which we will have two inputs. So we just need to put in the dip switch and the IC, secure both materials with a line to supply them with power, and ground them. Now all we have to do now is properly insert the connecting wires to its proper place by following the schematics. Now that it's complete, time to test it using our logic probe. And this is what we have observed. The output will only be high when both inputs are also high, and low if otherwise. The final item to be demoed will be the combination of the three, in which we are tasked to make this kind of logic circuit and determine its output at point X. And due to some circumstances, this video was sped up so that it won't go over the time limit. Just a reminder that the concepts used in the previous circuits that we had demoed will be used in this final setup. So just keep your eyes peeled and hopefully you can understand our demo. Now that we have finished making the combinational circuit, it is time to test it. And since point X lies at the positive base of the LED, we will put our logic probe in that same terminal to begin testing. To help us remember more effectively, we will just type in the combinational input that will make our output high. Since we're done tallying the combinational inputs, it is now time to put them inside the truth table as shown. And we also included the equation for the given combinational circuit at the top part of the table. Now this sums up our Laboratory 3. Thank you for watching.